Hello, my name is Eddie Britt, and here is your Test 1 video review. So I'm going to try to work through this as fast as I can. So if you need to, pause or rewind if I seem to go too fast. Alright, let's look at problem number 1. This is solve and check the linear equation. Of course, this is a test, so you don't have to check it if you don't have the time. But if you have the time, then do go through and check it. But I probably won't check it just to save time. Alright, so there's a negative in front of this parentheses here, so make sure you distribute a -1 or change the signs of both of the terms inside the parentheses. So that would give you 4x minus 3x plus 1 equals 2. And so that's 1, when you put the x's together, that's 1x plus 1 equals 2. Subtract 1 from both sides and you get x equals 1. So the answer here is A. Alright, number 2, I don't have anything in front of this parentheses right here, so you can get rid of the parentheses. Also on the right side of the equation, there's a 4 in front of the parentheses, so you need to distribute that to both terms. So that gives you 3x minus 1, and then you have another minus 1, equals 4 times x is 4x, 4 times -5 is -20. So that's going to be, I'm just going to keep working over to the side here. That's going to be 3x minus 2 equals 4x minus 20. Now, I have variables on both sides, constants on both sides. It doesn't matter what side you move your variable to. But I usually try to move my variable to the left when I can. So I'm going to move my 4x over. So that cancels out there. On the left side of the equation, that's going to give me a -1x. And then I have minus 2 equals -20. So add 2 to both sides to move the constant over to the right side of the equation. I have -1x equals -18. Divide both sides by -1, and I get x equals +18. So that is also A. Number 3, it says first write the values that make the denominator 0. So those are restrictions. So the only way you can make this denominator, this 1x to the first power, or 2x to the first power, the only way you can make those 0, since you have a product or no number in front, which we really have a 1, is by letting it equal 0. So x cannot equal 0. That's a restriction. If you look at your choices down here, you see that 3 of them have x cannot be equal to 0. So definitely not D. Because we do have a restriction. Now, you multiply through by the least common denominator to get rid of the denominators. So you need to look at the numbers, which I have a 1 and a 2, and then this is like a over 1. And so I'll bring out you got to bring out the smallest number that all of the constants or coefficients will divide into, which is a 2. And then I'm going to take x to the first power, take the highest power of x. So I'm going to multiply each term by 2x. So whenever I do that, I'll do that over the side here. That's 2x times 9 over x equals 2x times 3 over 2x plus 2x times 60. This is where all of your denominators should go away. If they don't, you did something wrong. So here you see my x's cancel out. 2 times 9 is 18. And here my 2x's cancel out. That leaves me with a 3. And then plus 2x times 60 is 120x. So I subtract 3 from both sides, and I get 15 equals 120x. Divide both sides by 120. This is definitely a fraction that will simplify. You can divide the numerator and denominator by 5. So whenever you do that, you should get, you can probably divide them by 15 now that I look at it. If I divided them by 5 though, I would have 3 and 24, which then I could simplify again and divide by 3. It's 1/8. So x is equal to 1/8. So x cannot be equal to 0, and the solution set is 1/8. Now on the next problem. Look at all of the denominators. We want to see what we would have to plug in for x to make any of the denominators equal to 0. You can see a -2 and a +2 would make those 0. Also, a -2 would make this term 0, and a +2 would make this term 0. So that's our two restrictions. X cannot be equal to 2 or -2. Alright, so if you look down here, you'll see restrictions. This has no restrictions, so that's wrong. This just has one restriction, so that's wrong. So it's either got to be A, an answer of 3, or B, no solution. So let's go through, multiply through by the least common denominator. And so we got to take each denominator or each factor once. So I'm going to multiply everything by x plus 2 times x minus 2. So whenever I do that, I could write it all out. But whenever I do that, I'm multiplying it times each term. And what's going to happen is when I multiply this common denominator times 3 over x plus 2, the x plus 2's are going to cancel out, and it's going to leave me with 3 times x minus 2. So I just want to write over here 3 times x minus 2. And then I have plus. Now I want to do the same thing for the next term. If I multiply this next term times x plus 2 times x minus 2, look at the denominator here, x minus 2. So the x minus 2's are going to cancel out. So I'm going to have plus 1, which I really don't have to write that there, but 1 times x plus 2, that's what was left over. And then equals, here I have both terms in the denominator, so when I multiply this term times both of these terms, all of that cancels out and just leaves me with a 4. So now I have this simple linear equation. So distribute your 3x minus 6. You don't have to do anything with a 1 or distribute your 1. You get plus x plus 2 equals 4. So put your x's together, that'll be 4x. Put your constants together, that'll be minus 4 equals 4. All right, plus 4 plus 4. 4x equals 8. Divide by 4, divide by 4. So I have x equals 2. Now, remember that you have to check your answer back with the restriction. One of the restrictions was positive 2, and I got my answer as positive 2. When that happens, it means we don't take this answer, and the answer is no solution. So your answer is B there. All right. On the next problem, look at all of the denominators, and you can see that letting x equals 1 is going to make two of the denominators equal to 0. The other term doesn't have a denominator. So x cannot be equal to 1. That's my restriction. So if we look down here, you see x cannot be equal to 1 on A. B says x cannot be equal to -1, so we know it's not that one. C says x equals 1, so that may be the answer. And then D says x equals -1, so we know that's not the answer. Because the only number we have to leave out of our possible solutions is positive 1. So now take the least common denominator, which is going to be just x minus 1. There are no constants in the denominators that you have to account for. And we're going to multiply the entire equation by x minus 1. So remember, when I do that times the first term, look what would cancel out. The x minus 1's would cancel out and just leave me with an 8. And then plus, now here for the second term, I don't have a denominator. So whenever you don't have a denominator, you just multiply that number times the common denominator. So it's going to be plus 1 times x minus 1. But multiplying everything times 1 is not going to do anything. So you can write that there or not. And then put equals. When you multiply that times the last term here, those denominators can't, that common denominator cancels that denominator out and leaves you with a 6. So I'm going to have 8 plus x minus 1 equals 6. So I'm going to put my two constants together there, and I'll have x plus 7 equals 6. And so I subtract 7 from both sides to get my solution x equals -1. So look at the restriction. The restriction is +1, so that's okay. So x could not be equal to +1. That's the number we have to leave out. And then x equals -1 is my answer. And that's what A says here. X is not equal to 1, and -1 is the solution. All right, on problem number 3, it's a little different from the previous problems because you can see there's no x in the denominator, only in the numerator. So when you don't have any x's in the denominator, you're not going to have any restrictions. So we just want to take the least common denominator and multiply that times the entire equation. So let's look at our denominators. We have a 5 and a 3. So we're going to take and we're going to multiply that entire equation by the least common denominator for 5 and 3, which is 15. All right, so I can do the same thing that I was doing up here and kind of skip a step and not write it down 3 times and say 15 divided by 5, that would give me 3. And so I say 3 times 2x equals 15 divided by 3 is 5. So 5 times x is 5x. And then be careful, notice this last term here doesn't have a denominator. So you just have to say 15 times 3, and that gives you 45. So I have 6x equals 5x plus 45. Get the x's on one side. I'm going to move that to the left side. You can see I got 1x equals 45. So that's my answer. All right, problem number 7, we want to solve the formula d equals RT for R. So to solve for R, you want to get R by itself. You see, this is R times T on the right side of the equation. Since you're multiplying on the right side, to move something over or get rid of it, you want to divide. So I want to get rid of the T. So I'll divide both sides of the equation by T, and the T on the right side of the equation goes away. So now I have R equals D over T, and that's my answer. R equals D over T. All right, on the next problem, we have P equals 2W plus 2L. That formula may look, or in the previous formula, that may look familiar because they are used in math. The first formula was distance equals rate times time. This one is perimeter for a rectangle. So on this one, we want to solve for W. So first, get the term that has a W in it, the 2W, get that by itself. See, there's a term in front of it, the 2L, that we need to move over to the left side of the equation. That's a positive 2L, so I'm going to subtract 2L from both sides of the equation. When I do that, I'll have P minus 2L equals 2W, right? Because we moved the L term over. Now get the W by itself. To do that, you divide both sides of the equation by what's in front of the W, the 2. Make sure you divide the entire side of the equation by 2 like that. All right, and we can't cancel these 2's out on the left side. You say, why? Because we have P divided by 2 and minus 2L divided by 2. So we're going to leave it just like that. All right, so the answer here, again, is A. W equals P minus 2L all over 2. All right, on number 9, we want to solve for B. All right, so it's a little trickier because you see you got a number in front of B. We got to get rid of the number. And we have a letter H behind B. So what this means is 1/2 times base times height. That may sound familiar. That's the area of a triangle. And we do have A equals for area. So what we want to do, to get rid of the 1/2, you would want to multiply both sides of the equation by 2. So if I do that, if I multiply the left side and the right side both by 2, then you can see the number on the right side is going to go away and just leave me with a 1 in front of the BH. So I have 2A equals B times H. So now I'm solving for B, and since I'm multiplying here to get B by itself, I divide both sides of the equation by H. So B equals 2A over H. Okay. Number 10, this wants us to write an equation and solve. So it says when 3 times a number is subtracted from 7 times a number, the result is 44. All right, students get this problem confused and usually write it backwards because you don't just write it the way that in the order that everything is given. So it says 3 times a number. What would 3 times a number be? That would be 3x, right? But it says is subtracted from. All right, so if I said something like 25 cents is subtracted from $1, you would say $1 minus 25 cents, right? So here, 3 times the number is subtracted from 7 times the number. So 7x would be 7 times the number. So we want to say 3 times the number, 3x, subtracted from 7x. And it says the result is 44. So 7x minus 3x is 4x. Again, students usually mix those two up, so make sure you don't mix that up. Because if you do mix those two up, you would have got negative 4x, and then you'll get the wrong answer. All right, so I have x equals 11. That's my answer. You can see the negative answer is there too, so make sure that you put these in order. All right, on number 11, a car rental agency charges $175 per week plus 25 cents per mile to rent a car. How many miles can you travel in 1 week for $375? I've got a lot of stuff going on here. So first I'm going to set up an equation to give you the cost. All right, and it says a car rental agency charges, so they're going to charge $175 plus 25 cents per mile. So it's 0.25 is 25 cents, and then x, my variable, per mile. Now, it wants to know how many miles can you travel in 1 week for $375. So remember, x is our miles. So if the cost, if I'm going to pay $375 for the car, that is $175 plus 25 cents per mile. If I solve for x there, now I can get the number of miles that I could go if I was to give them $375. So we're going to get the x by itself. We're going to subtract 175 from both sides. That's going to leave me with 200 equals 0.25x. You may want to use a calculator here. You don't have to, but divide both sides by 0.25. All right, and I'm going to check my answer. 200 divided by 0.25, and I got 800. So x equals 800. So that means I can go 800 miles for $375 at that travel agency. All right, number 12 says, inclusive of a 7.9% sales tax, a diamond ring sold for $2,050.10. Find the price of the ring before the tax was added. So let's just use a little common sense here and think for a second. If we ended up paying $2,050.10 for a diamond ring total, that's after taxes, then do you think the original price would be more or would be less? Well, you add tax onto something whenever you have to pay for it. So the original price that you see in the store, it's going to be less. But then they're going to add those taxes on, right? So our answer that we get should be less than $2,050.10 for the price that you would look at if it was under the glass where you're looking at the rings. So there's really, we know it's not going to be C because that's more, a lot more. We know it's not going to be B because that's a real small amount. Now, so I would say it's going to have to be A or D. So that's just using a little common sense, right? The way tax works. So if I want to know, let's let X be the price of the ring before the tax was added. So whenever we have the price of the ring, what would we do? How would we find the tax to go on the ring? I would say plus, and it said 7.9% sales tax. To write that as a decimal, it's not 0.79, that would be 79%. It's 0.079 times the price of the ring. So we know the price, the original price of the ring plus 7.9% times the price of the ring was equal to $2,050.10. So now we just need to remember there's a 1 in front of this x, even if I don't write it. So when I add those together, I'm going to have 1.079x equals $2,050.10. So divide both sides of the equation by 1.079. And remember, the answer that we get has to be less than the value that's given in the problem, because the value that's given in the problem, the $2,050.10, that was with tax. So we want to see what would be before tax. So we do that division. I highly suggest using some type of calculator when you do it. And I got x equals 1900 exactly. So if you're looking at that in the store under glass, it's 1900. And then if you're charged 7.9% sales tax, the final price was $2,050.10. All right, let's look at number 13. Number 13 is a problem where drawing a picture may help. It says the length of a rectangular room is 6 feet longer than twice the width. If the room's perimeter is 156 feet, what are the room's dimensions? So definitely draw a picture here. I'm going to draw a rectangle, a small rectangle here. And we have that the length of the rectangular room is 6 feet longer than twice the width. So let's call the width x. So this side is x. And if this side is x, this side has to be x because it's a rectangle. And it says the length is 6 feet longer than twice the width. So twice the width would be 2x. And 6 feet longer would be plus 6. So if the bottom part here is 2x plus 6, the top part here is 2x plus 6. All right, again, we made the width x, and then we were told in the problem that the length was 6 feet more than twice the width. That's why I have 2x plus 6. All right, we're also told that the perimeter, that's all the way around, is equal to 156 feet. And now we want to know the dimensions, the width and the length. Now, if we can solve for x, we will have the width. Once we have the width, if we come back and plug it in, 2x plus 6, we'll have the length. So let's add all the sides up, because that's what perimeter means. So we have x plus 2x plus 6 plus x plus 2x plus 6. All right, so that's going to be 6x plus 12 equals 156. Because we were told the perimeter is 156. Now, if we solve for x, it's not going to give us the width and the length. That's just going to be the width. So minus 12 minus 12. So 6x equals 144 divided by 6, or 143. No, 144, I'm sorry. Divide by 6, divide by 6. So x equals, it's going to be 24, I believe. So our width is 24. That equals our width. All right, so our length, if we plug this back in where it said the length is 6 more feet than twice the width, so we say 2 times 24 plus 6, and that's going to be the length. So that is 48 plus 6, and 48 plus 6 is going to be 54. So that's the length. So the width was 24 and the length was 54. So that's going to be A. All right, number 14 says determine whether the given ordered pair is a solution of the system. So if you're this, basically it says, is this an answer for that system of equations? The way you can tell that is if you plug in a 3 for your x and a -4 for your y in each equation separately, you should get two true statements. If you do, it's a solution. If you get one that's false or both that's false, it's not a solution. One or both, it's not a solution. All right, so if I plug in a 3 for my x, that's 2 times 3, or 6, and plug in a -4 for my y, so it's going to be 6 minus 4 equals 2. So 2 equals 2. That works out. That's a true statement. Let's plug it in the second equation. Let's plug in a 3 for the x, 4 times 3, plus 2 times, plug in a -4 for your y, equals 4. So 12 minus 8 equals 4. 4 equals 4. So those are both true statements. Since they're both true statements, that means that that is a solution. All right. Number 15 is the same type of problem. Let's plug in -1, -5. So that's my x and that's my y. So plug in a -1 for your x. It's 2 times -1. Now be careful here. You have a minus and then plug in a -5 for your y. Then I have equals -7. All right, so let's see. 2 times -1 is -2. And then I have minus -5. So that's going to be plus 5 equals -7. Uh-oh. So I have 3 equals -7. That's a false statement. So I don't even have to go any further. I could just stop right there and say that's not a solution. Because if you plug your ordered pair, your x and y, into either equation and get a false statement, it's no solution. All right, number 16 says to solve by the substitution method. So for the substitution method, what we want to do is we want to get one of the variables by itself. All right, and we want it to be a 1 in front of the variable. So if I look down at my two equations, I already have y solved for in my first equation. So what we want to do is we want to take this 3x plus 2 and we want to plug it in parentheses for my y in my other equation. Now make sure you plug it in parentheses because you see I have a 5 in front there. So I have 5 in front of my y, so 5 times 3x plus 2, and then I'm going to say plus 15x equals -80. So you can see all I did was plug in 3x plus 2 for my y because y was already solved for. So that made it a lot easier. So now work this linear equation out. All right, so that's going to be 15x plus 10 plus 15x equals -80. So that's going to be 30x plus 10 equals -80. Subtract 10 from both sides of the equation. And when I do that, I'm going to have 30x equals -90. Divide both sides of the equation by 30 to get x by itself. And I get x equals -3. So once you've solved for one of the variables, you can plug this into either equation. However, what I would do is I would come to where you had y solved for already. You have y equals 3x plus 2. And plug your x in, plug your -3 in for that x. That's the easiest way. So if I plug in a -3 there, I'm going to have 3 times -3 plus 2. That's -9 plus 2. So I'm going to get y equals -7. So my ordered pair is going to be -3, -7. All right, that's my x and that's my y. If you look down here, -3, -7, that's going to be C. All right, number 17 has the same directions. So what we're looking for, if we don't have a variable already solved for, is a variable to the first power, because we can always solve for that easily. So when I look at my two equations, I have an x and a y in both equations, but I have one of my x's, my x right here, this one, 1x. It is on the right side of the equation with a constant term, but to solve for it, all I'd have to do is move the constant over. So I have x equals 4y, and then when I move the 64 over, it'd be minus 64. Alright, so what I'm going to do now is I'm going to take and I'm going to plug for x in the other equation. I'm going to plug in 4y minus 64. There's a 3 in front there, so when you write this, say 3, and then make sure you put this in parentheses, times 4y minus 64. Then I have plus 12y equals 0. So I want to distribute here. I have 12y minus 64 times 3 is 192 plus 12y equals 0. 12y and 12y, that's 24y minus 162 equals 0. Move your constant over, so you'd add 192 to both sides. I may have said 162, I meant 192 to both sides. So 24y equals 192. Divide both sides by 24. If I do this in a calculator, I bet I'm going to get a whole number. Let's see. Y equals 8. Now that I know what y is equal to, I look over here and I see where I had x equals, and I'm going to plug in an 8 for my y. So x equals 4 times 8 minus 64, or 32 minus 64, which is equal to negative 32. Alright, so the way that I need to write my answer there, my x is, I just solved for, negative 32. My y is 8. Alright, so I believe that's supposed to be right here. I'll make sure that that is correct on your test. The 8 wasn't written in, so that's the right answer. Negative 32, 8. Number 18 says to work this by the addition method. The addition method is also called the elimination method. It's my favorite method. So the reason I like it so much is what we want to do is we want to get the same number in front of one of the variables, and we want to have the opposite sign. When that happens, we can add the two equations together and cancel one of the variables out. So this first problem, number 18, is set up perfectly to work with the addition method. If I add these two equations together, you can see my 4x and negative 4x cancel out. So now add the two y's together, and I'll get negative 6y, and then add the two, say equals, and now add the two constants together, and I get 12. So to solve for y, divide both sides by negative 6, so y equals negative 2. Once I know what y is equal to, now I can take that and plug it into either equation. I'm just going to plug it in the top equation. I usually choose that one every time. So that would be 4x plus 5 times y is negative 2, so negative 2 equals negative 6. Again, what did I just do? I solved for y, and I got negative 2. So I took where I have a y in my first equation, I plugged a negative 2 in. Now I'm going to solve for x. So I have 4x minus 10 equals negative 6. Add 10 to both sides, and I get 4x equals 4. So I got x equals 1. So my ordered pair is 1 for x and negative 2 for y. So that's my solution. All right. On this next problem, I need to work still by the addition method. All right. I want the same number in front with different signs. So you can see I have a 1x and a 1x here, but I need one of them to be negative. So what I can do is take and multiply the entire equation by negative 1. So that would give me negative 1x plus 7y equals negative 19. Again, I'm saying the negative 1 times all three terms. The reason why I do that is because now if I take the second equation and write it underneath here, I can add the two equations together. My x's cancel out, and I'm left with negative 1y equals 23. And so if I divide both sides by negative 1, I'm going to get, I'm sorry, not 23, 3. I'm going to divide both sides by negative 1, and I get y equals negative 3. There's only one answer down here where y equals negative 3. You can see this one right here. But let's make sure we get a negative 2 when we plug it back in. So you can take either equation, no matter which one. I'm going to take the top one here. And for the y, I'm going to plug in a negative 3. So I have x minus 7 times negative 3 equals 19. Or x plus 21 equals 19. Subtract 21 from both sides, and you can see x equals negative 2. So x is negative 2, y is negative 3. And that's the answer that I have right here. All right, the last problem says to use the method of your choice. So it doesn't matter how you work it out, elimination or substitution. I will tell you just by looking at it, you already have y solved for. So all you would really have to do is take the 15 minus 4x and plug it in for y. And then you'd be able to solve for x. So if I plug that in, I have 4x, and then I don't have a number in front of the y. So when I plug it in, I don't have to put it in parentheses. This is one of the only times that's happened. So plus 15 minus 4x equals 31. Well, I can see something looks a little different here. Something's a little crazy. Because I have a positive 4x and a negative 4x, and they cancel out. So they canceled out, and I'm left with a false statement. So if they cancel out and you're left with a false statement, that means that the answer is no solution. Okay? If we would have canceled out and gave us a true statement, it would be all row numbers. That's your test review. I hope that helps. Make sure you email me if you have any questions. Have a great day.